Okay, so with this help with exercise 10.2, what I'm going to do is a couple of them, and there's a couple of ways you can approach it. But with question 1, I decided to have a look at x squared minus 9 greater than 0 and say that that was the equivalent of me looking at x squared greater than 9. Y equals x squared is a helpful tool. It is a picture of x squared for various values of x, and there it is drawn there. It's a parabola. It's the most simple parabola we can have. So I've sketched it. And then I want to see which values of x have the y values that are greater than 9, because that's what I'm looking for. I'm looking for this y equals x squared to be greater than 9. Well, clearly it's the yellow section. That's the bit that's greater than 9. Now, which x values is going to generate that for us? Well, it's not going to be this section here, but it will be there and there. So how did I get the 3 and minus 3? Well, you solve to get the critical values. So you just set x squared equals to 9 and then get the values of x, and you get plus or minus 3. So they're the critical values, and then you have to decide, well, which side of those. And it's actually the outsides. It's less than minus 3 and greater than 3. So that's them there. Number 3, I had a look at a squared minus 2a greater than 0, and I had a look at the parabola that would help solve it, and that's y equals a squared minus 2a. Well, it's not in terms of x anymore, it's in terms of a, so note that I've got a here. So if I draw that parabola, what do I have to do? I have to find where the a intercepts are. So I set it equal to 0, because that gives me my a intercepts, or horizontal intercepts, and then I have found that they are 0 and 2. So this value here is 2. The 0 is already there. I know it's a concave up parabola because the coefficient of a squared is positive, it's just 1. So the parts of that curve which are going to be greater than 0, I've highlighted in yellow. Then I have to figure out, well, which bits of x work for that. So that bit works, not those x's there and those x's that are greater than 2 there. So not the x's between 0 and 2. So it'll be the a's that are less than 0 and the a's that are greater than 2. Let's look at 7. So what's the parabola that would be helpful here? Y equals x squared plus 2x minus 8. So I sketched that. First of all, I had to find the x-intercepts to be able to do it. So if you solve equal to 0, do a bit of work, you'll find that x is minus 4 and x equals 2 are the x-intercepts. So then I have to figure out, well, which bits of those are, of that parabola is greater than 0, and that's highlighted in yellow. There it is there. So which bits of x produce that? Well, not the bits in the middle, but the bits on the outside. They're the x values that work. So that means I'd have to grab x less than minus 4 and x greater than 2 as my answers. Let's look at 10. So the associated parabola is going to be y equals minus x squared minus x plus 6. It's a concave down one. I find the x-intercepts as usual. They're minus 3 and 2. Then I see, well, which part of that parabola is less than 0. That's what they want, less than 0. Well, there it is, all that bit under there and there. So which values of x actually produce that for me? Well, those values of x there, not those, and those ones there. So that gives me x has got to be less than or equal to minus 3, and x has got to be greater than or equal to 2. Let's have a look at another one. So here we've got trying to solve 2h squared minus 7h plus 6 less than 0. So the first thing you notice, it actually shouldn't be an x there. Let me make it an h, because the variable is h, not x. Everything else can be the same. So as usual, we find our h-intercepts. I found them to be 1.5 and 2. And then I'm looking for the bit that's less than 0. So that's this bit that dips under here. So which bits of the h values work? Well, it's not these h values down here. It is these and not those. So it's actually in between those critical values. So the h values, oh, I'm going to have to fix that because I've got an x. Sometimes that happens. So the ones that actually work are going to be 1.5 up to 2, but not including because it's not an or equal to 1. 20. So you could actually expand that out, bring everything over to one side and treat it as a different parabola. But I didn't bother. I thought, well, it's much easier for me to just draw this parabola, right, which is here, and then see where is it greater than or equal to 5. All right. Well, the reason I did that was because it's set up ready to go for me to find the x-intercepts, which are 3 and -1. So there they are, 3 and -1. Now I want to see where is this greater than 5. Well, it's only this bit here. Right, you can see there. Now which x values are going to produce that? All these ones here, not these, and all these ones here. So how do I know what this position is here and this position is here? Well, I have to actually solve this one and find out. Now you could expand it out and do your usual, but I found it easy just to look at that, and by inspection, just trying a couple of quick easy numbers, I actually found that 4 and -2 were the answers. I did that by inspection. If that's, if it's not going to be a nice whole number, that won't work. But it was worth me spending 10 seconds looking to see if I could do that. So the values now are going to be x is less than or equal to -2 and x is greater than or equal to 4. Hope that helps.